Hi, good afternoon everybody. This is Glenna from the Sea Science Center. Today we're going to be doing a demonstration on prisms. If you've ever wondered what color the light is that comes from the sun, today you're going to be able to figure that out. We're going to head outside in just a few minutes to demonstrate what a prism looks like to you and to see what colors we can create from the sun. But first I'm going to tell you about some of the supplies that you're going to need to do this. You will need a piece of cardboard, a big piece of cardboard, and what you need to do is put a hole in the middle of it big enough that a pencil could go through. You will also need a white piece of paper. I have taped my white piece of paper to a book to make it a little bit more flat and easy to maneuver around. Scissors and a pencil, tape to tape the paper on. You will need water, and you will need a clear glass. You're going to pour water into the glass. Okay. All right, so we have moved outside. It is a nice sunny day outside today, which is the perfect day for us to test out our prism. So the first thing you need to do is fill up your glass with water. And we're going to fill it about, I would say about 3/4 of the way up. A little bit more maybe. That's good. All right, perfect. Okay, so now what you want to do is you want to lift up your cardboard so it's kind of at an angle. And you may need help to be able to do this, so don't be afraid to ask for help. And you're going to pick up your glass and you're going to place your glass behind the cardboard so that the light from the sun passes through the water onto the white paper. The light that we see from the sun appears white to us, but sunlight is actually composed of many different colors. When white sunlight enters a prism, the different colors slow down to different speeds and are bent at different angles. This is what happens when we see a rainbow. We can see that white light is made up of red, orange, yellow, green, blue, indigo, and violet light. These colors are sometimes called Roy G. Biv, the colors of the rainbow. Oh, that's a good one right there.
Hello, this is Adele. As Glenna and Ariana just showed you, sunlight has many different colors, but it also has invisible light as well that we can't see. Your sunglasses protect you from ultraviolet light, and most of the heat that you feel on a sunny day is from infrared. Anything that has heat radiates infrared light, including your body. That's how firefighters can use a special camera to find you if there's a fire. Even though they can't see, they can see that you're giving off heat. So the sun sends radiation, that's light and heat, down to the earth. Some of it is reflected by our atmosphere, but some of it passes through and is absorbed by our planet. Then at night, when the planet cools off, it radiates it out back to space. Some of it gets trapped by molecules in the atmosphere, keeping the Earth warm. This is necessary to keep the planet warm enough to grow plants and for life. The atmosphere is made up of molecules. We can feel the air moving around us, especially when it's windy. And 99% of our atmosphere is nitrogen and oxygen. And this is a model of those molecules. You can see they're very stiff. They can bounce off of things and bounce off to each other. They're very stiff. A small part of our atmosphere is made up of greenhouse gases. Those are the ones that capture that heat energy, the infrared heat, and radiate some of it back to the earth to keep the earth warm. This is a model of a carbon dioxide model. You can see it behaves very differently from the nitrogen and the oxygen. It's a lot more flexible, and that's what allows it to absorb the infrared radiation, that infrared light. So scientists are able to measure how much carbon dioxide is in our atmosphere and understand how that affects our. I'm going to share with you how you can make some models of our atmospheric gases, the molecules, for yourself so you can feel what the properties are. Just like Animals have different properties and plants have different properties. Molecules have different properties as well, even though they're invisible. So you'll be able to feel them and experience those properties for yourself with these models that we're going to make. So I got the materials all gathered up for our activity. I've got some spaghetti. You can also use toothpicks. I'm also going to use those as a tool. I've got marshmallows, but you could also use Play-Doh or gumdrops or whatever you have. I got some plastic from the recycle bin. I got a ruler, some scissors, some tape, and a marker. Our molecules are going to be different sizes. Our molecules of nitrogen and oxygen will be fairly similar. We're going to make the oxygen 2 inches, and we're going to make the nitrogen 1.5 inches, a little bit smaller. So I'm going to use the spaghetti. So I'm going to take 3 strands of spaghetti and tape them together to make them nice and strong, like the bonds between those molecules are pretty strong. Then I'm going to measure them and cut them one section to 2 inches and one section just 1.5 inches. So I labeled the marshmallows 4 oxygen molecules, 1 carbon and 2 nitrogen. If you're using Play-Doh or gumdrops, you can designate different colors for each element. Remember not to eat the marshmallows after you write on them. Then I'm going to take the longer section of spaghetti and I'm going to put the oxygen on those. To make an oxygen molecule, 2 oxygens bond together to make an oxygen molecule. And same thing, 2 nitrogen molecules bind together to make nitrogen in our atmosphere. So there's our 2 model molecules for this. So I've got some plastic from the recycle bin here. I'm going to cut a thin strip of it around the edge here. Maybe an adult to help you with this. Carbon dioxide molecule is going to be 5.5 inches long. For the carbon molecule, I'm going to take a toothpick and I'm going to make a hole through the middle of it. Kind of work it through a little bit so there's a definite hole in that marshmallow. Then I'm going to take the plastic and I'm going to push it through because the carbon molecule goes in the middle. Make it roundish again. There we go. So there's our carbon molecule. And I'm going to add oxygen to either end. There we go. So now we have a carbon dioxide molecule. You can see it's a lot more flexible than our rigid oxygen and nitrogen molecules. So I hope you try this and share it with your family and join us next time.